Every elements in Z10 to the symbol is present in the table and no other elements other than those are present. Furthermore, every elements in Z10 is present in every rows of the table. And now we are just notifying that what is the meaning of Z10 to the symbol. It turns out that this is true for all n. Zn is closed under multiplication mod n. This is the very important topic called Fermat's Little theorem, and there are large uses of this concept, this theorem, while we are solving the problems of the theory of numbers. The Fermat's Little theorem states if p is prime and a is a positive integer not divisible by p, then a to the power p minus 1 is congruent to 1 mod p. If we multiply both sides by a, we can come up with an alternative form. A to the power p minus 1 into a is congruent to a to the power p, congruent to a mod p. And the second is Euler's tosient function. An important quantity in number theory is Euler's tosient function, the number of positive integers less than n that are relatively prime to n. It is written phi n, phi 1 equals 1, phi p equals p minus 1, phi m is less than m minus 1. Here for second case p must be prime and here m is composite. In other words, Euler tosient function phi n is the number of every elements in Zn dashed. Assume we have two distinct prime numbers p and q and an integer n equals pq, then phi n equals phi pq, phi p into phi q equals p minus 1 into q minus 1. The set of residue in Zn is 0, 1, 2, 3, 4 dot dot pq minus 1. The residue that are not relatively prime to n are the set p 2p up to dot dot q minus 1 into p, the set q 2p 2q dot 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 up to p minus 1 into q, and 0. So phi n equals pq minus of q minus 1 plus p minus 1 plus 1, and pq minus of p plus q plus 1, p minus 1 into q minus 1, phi p into phi q.